America's first steam-electric locomotive. Without question, the most forward-looking design of motive power since the beginning of railroading. It represents the cooperative efforts of Union Pacific and General Electric engineers to do what had never been done before. They put a high-pressure condensing turbine electric power plant to work on the railroad. Now, steam and electricity work together on a new transportation job. Steam, traditionally the source of locomotive power, electricity, the smoothest, most flexible, and quietest means of transmitting that power, doing twice the work of a conventional steam locomotive per pound of fuel. Everyone who had an opportunity to see this locomotive as it was being assembled in the factory marveled at the small size of the steam turbines that furnish its power. 5,000 horsepower from 4 of these little machines. They turn more than 12,000 revolutions a minute. And besides all the power for the traction motors, they generate enough more for all the requirements of a 12-car Pullman train. Speaking of innovations, the new boiler used in this locomotive comes in for its share of glory, too. It holds only 50 gallons of water and is designed for rapid steaming. Starting cold, you can raise the steam from 0 to full pressure within 15 minutes. Firing is begun automatically at the touch of a button, and during operation, the rate of firing increases and decreases automatically with the load. One of these 2 armature direct current generators supplies the power for the driving motors. It is driven by the turbine through a gear reduction of 10 to 1. An alternating current generator is also connected to the main generator shaft, furnishing power for train air conditioning, traction motor blowers, and other accessories. The variety of the equipment involved and the diversity of the problems encountered and their solutions all have made this one of the most outstanding engineering developments in, well, a good many years. Of course, many were sure it couldn't be done. They said, what? Use the boiler feed water over and over? Condense high-pressure steam with air on a mobile unit? No, it never had been done. So General Electric tackled it. When all the equipment had been assembled in the GE works at Erie, they had a locomotive unit 90 feet and 10 inches long. This in itself is something of a record for size, and remember, we're talking now of only 1 unit. 2 of these make up the 5,000 horsepower that Union Pacific needed to climb the 2% grades in the Rockies and to attain speeds up to 125 miles an hour on the level. Behind these vanes on the sides of the locomotive are the air-cooled condensing units. The vanes open and close automatically, admitting the right amount of air to provide the proper condensing rate under all conditions. Wide variations of load, outside temperatures ranging from 40 degrees below 0 to 115 above. Atmospheric conditions ranging from sea level to mountain passes 8,000 feet above. Putting the big cab onto the trucks is all in the day's work for the lifting cranes in this shop. For years, they've been helping assemble electric locomotives, some of them veritable giants of the rail, but none quite as big as the new steam electric. Finally came the great moment for the new baby to see the light of day. Its unusual length called for extraordinary care in moving it from the assembly floor to the test track. Thorough checking of the power plant and electric controls completed, the first unit is ready for the running test. But wait, an event as memorable as this in the story of American railroading calls for appropriate christening ceremonies. So, Mr. Walter Janke, assistant to the general mechanical engineer of the Union Pacific, steps up to do the honors. And unit number 1 moves away under its own power. General Electric's 4-mile test track at Erie, which is laid with heavy rail, was used, of course, for the initial proving ground. Many of the electric locomotives in operation throughout the world have been put through their paces on this track. Believe it or not, this is the engineer's view from the cab of a steam locomotive. And here on this relatively short stretch was a good place to try out the brakes, which include electric brakes in addition to air brakes. 6 of these big traction motors are used to drive each of the 2,500 horsepower units. When the engineer applies his brakes, the motors automatically become generators, sending electric current through this special water-cooled resistor, which reduces the speed of the train smoothly and easily. Following the light locomotive test, runs were made with a train of loaded coal hoppers, having a weight equivalent to that of a heavy passenger train. Then, thanks to the cooperation of the New York Central, arrangements were made to use the main line between Erie and Dunkirk for more exacting running tests. Here, with a train of 7 cars, one 2,500 horsepower unit easily reached the 80-mile speed limit on this section of the road. People commented on the modern appearance. They marveled at the almost complete absence of smoke and steam. Remember, the steam electric's exhaust is condensed and returned to the boiler to be used again and again. It's this feature and the high efficiency of the power plant that enabled it to get 700 miles between stops for fuel and water. General Electric's sales chief, E.O. Shreve, Transportation Vice President H.L. Andrews, and many more of the company's executives came to see the test run. And President Swope was there, seen here in company with Manager Emmett of the Erie Works. The men responsible for every phase of General Electric activities, all eager to see the newest in railroad motive power, Research Director Coolidge, Vice President Allen, Vice President Barnes of the New York District. And now for a ride. Engineering Vice President Muir leads the way up into the engineer's cab. Acceleration is swift, smooth, electric. No vibration, no pounding of rail. Motive power that's easy on the road maintenance budget and that pleases passengers. Even the company's board of directors turned out to see this new king of the rails. Chairman of the board, Owen D. Young, was there, recognizing this to be a real milestone in his company's progress. And B.E. Sonny, 80 years young. C.E. Wilson, Executive Vice President, climbs aboard. And now approved by its builders, including Babcock and Wilcox and Bailey Meter, who also furnished important equipment, it's ready to go to work. So Mr. Walter Yonick, veteran locomotive engineer of the Union Pacific, takes his place at the controls, ready to put the new locomotive into revenue service. First to Chicago, and then over the line he knows so well, to Los Angeles. Just 70 years ago, the construction of the Union Pacific was completed, the final link in the first transcontinental railroad, a pioneering enterprise if there ever was one. This year, the company turns to the steam electric for handling its important passenger schedules, a distinctly new type of motive power.